Today we're going to be talking about writing functions, and we want to start with this table. It says determine a relationship between x and y values. Write an equation. Well, when x is 5, y is 1. When x is 10, y is 2. When x is 15, y is 3. When x is 20, y is 4. And we can write that equation. We want to know what y is. Y equals something. Well, it looks like if you take whatever x is and you divide it by 5, you get your y, because 5 divided by 5 is 1, 10 divided by 5 is 2, 15 divided by 5 is 3, and 20 divided by 5 is 4. Okay, so now we want to move on to some vocabulary. An independent variable is the input of the function. It uses the x value. And a dependent variable is the output of a function. It uses the y variable. The y is the dependent, x is the independent. Now what we want to do is identify the independent and dependent variables in each situation. It says a painter must measure a room before deciding how much paint to buy. So let's write down, we have independent. Let's look at that, and dependent variables. And so we want to know, does the measure of the room depend on the amount of paint that the painter is going to buy, or does the amount of paint that the painter buys depend on the size of the room? Well, the amount of paint that he's going to buy depends on the size of the room. So it's the amount of the paint that is the dependent variable, and it is the room's measurements, or the size of the room, that's independent. The room's measurements are what determines the amount of paint that's going to be bought. So let's take a look at this next one. The height of a candle decreases d centimeters for every hour it burns. So again, we want to write down independent and dependent. And so you want to ask yourself, is the height of the candle dependent on the amount of hours that the candle burns? Or is the number of hours that the candle burns dependent on the height? And remember, the candle's going to go down in height the longer it burns. So the height is your dependent variable. The height depends on the number of hours, or the time that has passed when the candle's been burning. So let's continue. A veterinarian must weigh an animal before determining the amount of medication. So again, let's write down independent and dependent. Now, does the medication depend on the weight of the animal, or does the weight of the animal depend on the medication? And it's the amount, it's the weight of the animal that determines the amount of medication. So your amount of medication is your dependent variable, because that is dependent on the weight of the animal. Let me just get my pen working again. On the weight, sorry, there's the E, of the animal. Okay. So the weight of the animal determines the amount of the medication. Now, an algebraic expression that defines a function is what we call a function rule. If x is the independent variable and y is the dependent variable, then function notation for y is what we call f of x. So f of x and y really mean the same thing. And this is read f of x, where f names the function. Another way you can read this is y is a function of x. So y is equals, a function is your f, and then of x is parentheses. And this really isn't as complicated as it sounds. Let's identify the independent and dependent variables and write a rule in function notation for each situation. So the independent variable, for this problem, it says a math tutor charges $35 per hour. Now, so that means the cost, the amount that the tutor makes, or that you have to pay the tutor, depends on the number of hours. So the cost is your dependent variable. Now, your dependent variable is always your f of x. Your independent variable is the number of hours that the tutor works, and that is your x. All right, because the number of hours worked determines the cost that you pay the tutor. And the way we write this notation, the cost, which is f of x, is equal to 35 times the number of hours. So f of x equals 35x. You get the same thing if you replace f of x with y. You could say y equals 35x, but we want to use function notation, so we're going to use this f of x in place of y. A fitness center charges a $100 initiation fee. So, and also I want to add to this plus, I didn't finish typing this, plus $40 per month. All right, so the independent variable. Well, the number of months that you are a member of this fitness center determines your cost. So the independent variable is the number of months. Remember, that's your x. And the dependent variable is your cost. Remember, dependent is always your f of x. So if we now try to write our function, our cost, our f of x, is equal to your $100 initiation fee plus $40 times the number of months. So f of x is equal to 100 plus 40x. Let's move on. Evaluate each function for the given input values. Number 1, for f of x equals 3x plus 2, find f of x when x is 7 and when x is negative 4. So we're given f of x equals 3x plus 2. Now all this is a substitution problem. So if you want to find out the value when x is 7, this is what you're going to do. In place of x, you're going to put 7. So f of 7 is equal to 3 times 7 plus 2. So f of 7 is going to give you 21 plus 2, which is 23. Now let's do f of negative 4. So if x is negative 4, you are going to have f of negative 4 equals 3 times negative 4 plus 2. We're just going to plug that number right in place of x now. So f of negative 4 equals negative 12 plus 2. So f of negative 4 equals negative 10. Okay, so let's move on. Now, you don't always have to use an f to represent function notation. You can use other letters. Now, if you have g of t equals 1.5t minus 5, we want to find g of t when t is 6. So let's do g of 6. So we're going to have 1.5 times 6 minus 5. Well, 1.5 times 6 gives you 9. Minus 5 gives you 4. I'm just going to write it right across our paper. All right, now it says find g of t when t is negative 2. So g of negative 2. So we have 1.5 times negative 2 minus 5. So I have negative 3 minus 5, which gives you negative 8. So g of negative 2 is negative 8. Next, we have h of r equals 1/3 r plus 2. It says find h of r when r is 600 and when r is negative 12. So we have h of 600. So we're going to plug in 1/3 times 600 plus 2. Well, 1/3 of 600 is 200. 200 plus 2 is 202. So h of 600 is 202. Excuse me. H of negative 12. So we have 1/3 times negative 12 plus 2. Well, 1/3 of negative 12 is negative 4 plus 2 is negative 2. H of negative 12 gives you negative 2. Next problem. Joe has enough money to purchase 1, 2, or 3 DVDs at $15 each. Write a function to describe the situation. Find a reasonable domain and range for the function. Well, f of x is our cost. We want to know how much this costs. And let's say that x is the number of DVDs. That is your DVDs, and f of x is your cost. So f of x is equal to $15 times the number of DVDs because they're $15 a piece. So f of x equals 15x. So let's see. They want to know what the domain is for this function. Well, how many DVDs can he buy? Well, it tells you right in the problem. He can buy 1, 2, or 3 DVDs. So 1, 2, and 3 is our domain. Our range are all of our possible x values. Well, let's think about it. If he buys 1 DVD at $15, he'd spend $15. If he buys 2 DVDs at $15, he will have spent $30. 3 DVDs at $15, he would have spent $45. So your range is 15, 30, and 45. So that's it on writing functions today. Thank you for joining me.